Welcome to the channel. So today's video is about another Leetcode problem in which we will see that how we can solve this problem called design hash map. So they basically says us to just design a hash map. They have given us some functions like this, so that we have to make a constructor, we have to make a put, get and remove uh, function. But first of all, we'll see that what is basically the hash map and what's the you know intuition behind making a hash map. So you see, you know that we the searching is very important in terms of data structures, right? The searching of the data. So in case of the array, when we use an array, so let's talk about the sorted and unsorted one. We have a sorted array and we have an unsorted array. If we have an unsorted array, then you know that, oh okay, so you will take off and comparisons to basically search specific key or a specific, you can say, value uh, from the array, right? So you will take off n time, right? But if you talk about a sorted array, obviously you can think that you can use binary search in that case. So you will take off log n time, right? And the same as the other data structures, like if you use a bst, uh, uh, if you use a binary search tree, then your time complexity is the same of a log n, right? But we just want that, okay, we want less time complexity, okay? Because we will optimize it to of log n, right? But we want something to be of 1, like we want the time complexity to be very optimal one, right? So then comes the concept of hash maps. So what does the hash map do is we basically make a container of some size, right? And suppose that we have some values to place in this. Suppose I have some values from 0 to 3, right? I have these values, like I have to place 0, 1, 2, 3. But I want that, okay, I want to retrieve that data in all of one time, right? Okay, so what I will do is, I have the indexes. This is an array and I have some indexes, and I will use these values 0 to 3 to, as indexes, and I will store the values into this, right? So this concept seems to be very, very simple, that we just simply, make an array of some size and use the values given into, mapping that values to the indexes of the array. Okay, but what if we have given very, suppose big values, suppose if you are given these values, right, and you have to map it into an array. So what does we do? Okay, so you can say that, obviously, you can say, okay, I will make an array of size 131, right? If you make this, then you will say that, I will have an array and its last index would be 130. It's sorry, I will have to, place here, its last index is 130. And then what I will do, I will place these three values, or there is 128 here and I will place some value here, there's 129 here and I will place some value against it, and there's 130 and I will place some value against it. But what about the indexes from 0 to 127, right? It will simply go wasted. You are simply wasting your space to just optimize the time. Obviously it will take off one time, but you are not you are not optimally using your space, right? So how we can overcome this problem when we have given very large keys like this? Okay, so again, the simple answer to this problem is, we will again use these indexes from 0 to 2, right? And we will, map these values, these 128, to this value 0. and we will place some value against it, right? We will map this 129 to 1, we will map this 130 to 2, right? So we have somehow come to the alternative keys to this, right? Okay, so how do you know that you have to, like, obviously you have to make a general rule that how, if you have 128 you will come to 0, if you have 129 you will come to 1. And also this is for the inserting the data, that for 128 you have to insert the data in the zeroth index. And also for retrieving, when you were retrieving from the zeroth position, you should know that this is the data from the 128th key that we have been given. Okay, so I hope that this idea is clear. Okay, so we will also implement this hash map into this. Okay, so let's just discuss some more scenarios. Okay, so when we have created this container, right? Okay, so when we have created it and you have make a hash function, what does the hash function do? Previously I was talking about some rule that our keys are mapped to some specific index. So this is the function which does that. What it does is it will take a key, right, as its argument. Okay, I can tell you. Okay, this is a hash function which will take a key, and what it does, we have some size of the container, right? This is a container, suppose, or this is a container, right? And it will modulo the key to size. So whatever is returning to us, whatever index, because the return type is int, whatever the index is returning to us, we will it will be within our size, right? And every time when the key is same or maybe different, um, we'll see that if its mod result is the same, then it will point to the same location in the container. Suppose we have take two values. I will take some value. Suppose I will take x and I will take xx, right? These are two different values. Sorry, these are two different keys, right? These are two. Value is basically that thing which we place at the which will place at the index, at the key. Okay, so key and values are different. At the position of key you will place the value. Okay, so suppose we have these two keys, right, and you will place it, you will pass it into the hash function, and k mod size, right, it will return you some index. Okay, so suppose at times we have this location, so what we does, okay, so this concept is basically called collision, where at the same index you have two values, right? So what we does, we will use a linked list concept here, we will make a linked list out of this. So this is basically called a collision. So now we will move to the next concept. Okay, so we have seen previously that we are making a linked list when two keys are indexed to the same location, right? So we have placed some value. Let's okay, these are the keys which we have placed in the hash function, and when we reach at that location you have to place some value at this. Suppose I have placed 0 here, right? And suppose that I have placed not this, I have placed 1 here, right? Okay, so you will see that first of all we have that location when we have this key, right? And when we have passed this into the hash function, we will get the same location, but we have opted for a linked list, and we are, we have, traveled some location, and reach here, and then we have placed our next value. Okay, so this concept is basically called a collision, right? And to resolve a collision, because you know that this is forming a linked list, right? So if you have linked list, then it means that again, if you reach at this index in of 1, then you have to traverse till the length of this, which is O of n, right? Okay, in the worst case, right? So it means that again, you have to, search for of n time complexity. So what is the purpose of this hash map? Okay, so it means that we should have some, some resolution to this collision. Okay, so how we can resolve this collision? There are some methods which includes the open open hashing and close hashing. Okay, so what is a open and a close hashing? Okay, so this, in this question we will not entertain this concept of collision, right? This is a easy category question, and in this question there is no test case or use case, you can say, of collision. But I will give you a very brief concept of the collision. Okay, next, I was discussing about collision, that we can resolve the collision by open and by close hashing. So in the open hashing, like we have discussed, that it will form a linked list, it will form something like chains, right? So this is basically called open hashing, right? And when we talk about the close hashing, so we have some some more types, which is called the linear probing, the quadratic probing, and the double hashing, right? We will not go into the detail of these things, although I have discussed the open one, but this is basically the thing. Okay, obviously, on to the next videos I will go into the detail of this collision concept. Okay, back to the question. uh, we have been given the task of making a hash maps, right? I have given you the concept of hash map, but we will revise it again in a bit. Okay, okay, so what we will do, how we can make a hash map? First of all, let's see what the question says about the keys, right? Okay, so they say that the keys can range from 0 to 10 raised to power 6, right? It means that the the, the ending point, like the last values of the keys, are actually very, big. Okay, so what we does is, we will declare a vector of node static. This is a vector, right? You know that the vector is similar to an array, but it is dynamically made, right? So I have declared a vector. Suppose I have called it a map, right? And this is a vector of node static, right? Okay, so let's first see what is a node. This is a node, right? The node has three portions. One is the key, here resides the value, and here is the next, like the link to the next node. Fourth, the purpose may be to resolve collision in the open hashing concept. Like I have said you that maybe it will, point to some more indexes when there is a case of collisions. Okay, so there is a next pointer also, and these are basically the two constructors, right? Okay, so back to this location, we have see that we have declared a vector of node static, right? Here is a pointer, here is a pointer, which can store an address of a a node. These are basically, you can say that this is a vector of this location is basically the head of the linked list, right? Okay, And I have also given a size of 10 raised to power 6. Why? I have given a size of this plus 1, right? 10 raised to power 6 plus 1. Why? Because we want the keys to be 0 to 10 raised to power 6. Okay? Okay. So what we do now? We will use a constructor to, obviously we have to give it as some size. We have to initialize it, and I will give it this size, and I will initialize with a null pointer. So all it have is basically the null pointer right now. I have also made a hash function. Okay. So let's talk about the hash function, how we can make the hash function, how many ways are there to make a hash function. So there are numerous ways to make a hash function. There is a division method, there is a folding method, there is a mid square method. There are a lot of methods. For string, there are separate methods. But the most common and the most simplest one is this. But it also depends your problem set, that what keys are given to you, and according to that also you have to make a hash function. But the most common one is this. Okay. Okay, I have made a hash function. Okay, so now comes a very interesting function, which is the put function. Okay, so what we provided a key and a value. Okay, so what we do is, will give this key to the hash function, and it will by doing this it will return us some index. Suppose that index is this 2. Okay, so we will ensure that we have a null pointer here, right? So suppose, obviously we have to initialize it with the null pointer, and this is our first iteration, right? So here is a null, we know that. So we will declare a new node, right? It has some key value, and you know that if we don't pass the next, then it will set to null ptr according to the constructor which we have made. So it will declare a new node, and it will place here the key and the value. Suppose the key is 2 and the value is 100, right? And next ptr, we have the null, right? Here we have the null uh, pointing to the next node, because there is no next node. So in the next we have null. Okay, and we will place it like it is pointing to this node. Okay, so suppose that I have already some this key at this location, as they say that in the put, if the key already exists, you have to update the corresponding value. Suppose that I have 2 already here, and I have this node already here, right? And again I come up with this same key in the data set, right? Okay, we have been provided such a data set where there are multiple same keys. So I will again encounter with a 2. What I will do is, I will go to this node, and I will update its value, so to whatever value is in the data set. Suppose there are, this is 200. Okay, so this is the what function do. Let's talk about the get function. Okay, so the get function is a very interesting function. What it does, it basically first of all checks that whatever key is given, obviously we have to apply the hash function, and we need a hashed index, right? Okay, so first of all we will check that whether it is a null pointer, or because we have to get some value, and we have to first of all check that is this a null pointer. Okay, so um, suppose that we were talking about this location, right? The index which is returned, which is the hashed index, is this. And we will see there is a null pointer. Obviously it is not pointing to anywhere, right? Okay, so we'll return a -1. But if we get this location, so there is already some value here, and we have to return its value. Okay, so this is what the get function do. Let's talk about the remove function. So first of all, okay, we have been given a key, and we get a hash. This is also called the index which is returned is also called a hash code or a hashed index or hash. Okay, the hash which has returned to us, we will first of all check that in the map, uh, is it having null ptr. Suppose this is this location, this is having null ptr, so we will simply do a return, it will return to the main. Okay, okay, so we can use void, if you have a void you can use this return, obviously you will not return anything, this will just simply return to the main. Okay, and if it is not null ptr, right, what you will do, you will place a null ptr here because this is a remove function, and what you do is you will simply if this is that if this is the location which we have been, this is the hash we receive, we will go into this and we will place a null ptr because it is not having a null ptr at this point, so we will place a null ptr here, so now it is not pointing to anything, right? Okay, so in the part 2 I will discuss the second approach to solve this question. So the second approach is about using an array. As you can see that I have declared an array of size 10 raised to power 6 plus 1 because we need the index from 0 to 10 raised to power 6, as I have discussed in the previous approach, where we have made a vector of node static, right? Okay. Okay, so this approach is not basically defining the crux of a hash map, but obviously we can, for this question, for the sake of this question, for the sake of broaden your mindset and concept, you can obviously go for this, right? But the real crux and the real intuition of the hash map is within the previous first approach. Okay, okay, so they have just created an array of this size, and they basically says that, okay, in the constructor they basically says that they are taking the starting point and they are taking the whole size and they are initializing it with -1, so all the indices have -1, right? If I will make a few 1, so it will have -1, -1 and -1. Then in the put, what it is basically doing, it is basically suppose that, so there is no hash function, right? As I said that this is not the real crux of a hash map, so we will take from 10 s to power from 0 to 10 s to power 6, right? And suppose that if we have the key 0, right, so data of 0 is basically this location, and when we place our key, suppose the key is 100, we will place our key here, and if we encounter the same key again, like we have 0, so data of 0 we will update its value, suppose the new value is 200, right? And if we have to get the value, suppose they said that we have to return 0, key 0, right? So we will go to there and we will return this 200. Okay, and then the remove, basically what we does is, if we have been given the key of 0, so we basically override this with -1. So this is basically the second approach. Next we will discuss the third approach. Okay, so let's just discuss the third approach. Okay, so I have declared a vector of pair, right? So this is basically the MP which I have declared. This is a vector, and within the vector, and we have pairs of int and int, right? This is a int. You can say that this is a key and this is a value, right? Okay. So what we does, so first of all we have to resize it. I have given it a size of 5, right? And I will use this is the initial size, right? What the vector does, if first of all we have to initialize it using some size, and afterwards if the container needs more space, so it will allocate the double space. For example, if this container is filled with numbers, then it will double its size. Okay, okay, this is the basically functionality of the vector. So first of all we have to initialize with the size of 5, and we have to we have used a function called emplaceback. What it does, it basically insert a 0 0 value. For example, we have this location and it will emplace back, it will make a container like this and it will emplace back 0 0, right? And we have used map dot emplace back. It means that it will emplace 0 0 in all the values. Same with here, right? Okay, so next we have a put function. So what it does, obviously, this implementation is not according to the crux of hash map, because a hash map is made to store or retrieve the data in O of 1. And you can see that I have placed a for loop where I will locate where is the key, and I will uh, place a value, the new value to that key, right? So we have to iterate and we have to check where we have keep the key, right, where the key is residing over here. So if we doesn't find the key, we have to in place back. Suppose I have given 1 2. So what I will do, I have in place back basically makes a new block, right? And it will because there is a difference between this and pushback. Pushback basically push it at the back of the container, but this makes actually a new block and push it back. So we have a key and value. Suppose I have this and it will suppose what it does, it will push back 1 and 2. Suppose here it will push back 1 and here it will push back 2. Okay, so what does the get function do? We will have the key, and I will iterate through the container to see where is the key, and I will return it. If I doesn't find it, I will return -1. Okay, so next is the remove. Obviously I will start, this is the implementation of iterator. I have used a auto keyword, and I will start from the beginning till the end, and when I found it, I will found the key, I will use the erase function, right? And I will erase that block, right? And we basically does a return. So I hope that you like the video and understand the concept. If you like it, make sure to like and subscribe, and make sure to check the link of the GitHub repo. I have placed it in the description. So just thank you so much for watching the video.